Exercise 2.5, question number 4. Find adjoint of the following matrices. From that, see first one. It is a 2 by 2 matrix. Easy it is. So matrix A is given. You have to find adjoint of A. So same, you have to find the cofactors and then you have to find the adjoint. So in last exercise we have seen how to find the cofactors, and when you take its transpose it becomes adjoint. So see, A matrix is given. So first we will find minor. So minor of this 2 is leave that column and that row, so it is 5. So its cofactor is formula A11 is equal to minus 1 raised to 1, this 1 plus 1 into this minor, which is equal to 5, because here it is 2 means even number, so it becomes positive and this is 5. M12 is equal to M12 means this 3 means this row and this column goes and minor is 3. So A12 is equal to minus 1 raised to 1 plus 2 into 3. This minus 1 into 3 is 3. M21 means this and this is 1, so minus 3. A21 is equal to minus 1, 2 plus 3 into minus 3. So this minus 1 into minus 3 is 3. And M22 means of this minor you have to find this row and this column goes, so what remains 2. So M22 is equal to minus 1, 2 plus 2 means it becomes positive and this 2, so this is 2. Now we will first write cofactor matrix. Cofactor matrix is 5 minus 3 3 2, and how to find its adjoint? Take transpose of this. When you take transpose of cofactor, it becomes adjoint. So this is transpose means change the row into rows and columns. 5 minus 3 will become column and 3 2 will become this column. Next one, from that second one, it is 3 by 3 matrix. So 3 by 3 matrix is given. Now we will find its cofactor matrix. So first we will find minor. So minor of this 1 means this and this is eliminated, and you have to find determinant value of this 3 5 0 minus 1, which is minus 3. So A11 is equal to minus 1 raised to 1 plus 1 into minus 3, that is minus 3, because this is positive and this minus 3. M12 means this, so this and this will be eliminated. Minus 2 5 minus 2 1, find its value, it is 12. So A12 is equal to minus 1 raised to 1 plus 2 into 12, that is minus 12, because this is odd. Next, now M13 means, suppose this is the matrix, M13 means this will be eliminated. So this is the matrix A. So this is A13, this and this will be eliminated. Minus 2 3 minus 2 0. So the value of this determinant is 6, and A13 is minus 1 raised to 1 plus 3 into 6, that is this is even, so the value of cofactor is 6. Now M21 means this, so this and this is eliminated. So you have to find determinant of minus 1 2 0 minus 1, its value is 1, and A21 is equal to minus 1. Now M22 means this, M22, so this column and this row is eliminated. So 1 2 minus 2 1, after solving we will get 3. So A22 is equal to minus 1 raised to 2 plus 2 into 3, this is even, so it becomes positive and this 3. Now M23 means this column and this row is eliminated, and minus 1 1 minus 1 minus 2 0, value is minus 2, and here it comes 2. See, only you have to see here positive and negative and give sign to the minor. M31, same M31, M32, M33, same. In that way you have to find the values of the determinant and find the value of the cofactor. Now we will write its cofactor. So cofactor matrix is equal to 3 minus 12 6 minus 1 3 2 minus 11 minus 9 1. Now we will find its adjoint. So adjoint means take the transpose of this. So transpose of this is change the rows into columns. So minus 3 minus 1 11 minus 11 minus 12 3 minus 9 6 to 1 6 to 1. So this is the adjoint matrix of the given matrix A. Now the next sum, that is question number 5. Question number 5 is find inverse of the following matrices by the adjoint method. Here for finding inverse we are having two methods, by elementary transformation and by adjoint method. So first we will see adjoint method. For adjoint method, formula is there: A inverse is equal to 1 upon determinant value of A into adjoint of A. So in this way only you have to find adjoint of A, and determinant value of A you have to find, and using formula you have to find the A inverse. Now see, first we will see question number 5, first sum, which is easy one, 2 by 2 matrix. Now first we will find the determinant value of A. So write it in the this is matrix. Now we will write it in the determinant form. So how to solve the determinant? 3 minus 1, 3 into minus 1 is minus 3, minus 2 into minus 1 is minus 2. So its value is minus 1. So every time while finding by any method, when you find the inverse, you have to take this step first. Value of determinant is equal to minus 1, which is not equal to 0. Therefore A inverse exists. This always you have to write this first step. Okay, this first step you have to write. When it is value of determinant is not equal to 0, then only you have to solve the, we can find the inverse, means A inverse exists. Otherwise A inverse does not exist if it comes 0. Now first we will find the minor minor, and then according to that we will find the adjoint. M11 means this row and this column goes minus 1. So by the formula minus 1 raised to I plus j into minor. So we get 4 values of cofactors. So write its cofactor matrix. Cofactor matrix, then that cofactor matrix we will write as adjoint matrix, means take the transpose of this matrix, you will get the adjoint matrix. Now use the formula. A inverse is equal to 1 upon determinant of A into adjoint of A. So 1 upon, what is determinant value we got? Minus 1, and this adjoint. So minus 1 multiply inside, so sign will change, and A inverse will be 1 minus 1, 2 minus 3. Now next one, question number 6. Question number 6, find the inverse by transformation method. When like this question is there, you can use the row transformation or column transformation. By any method you can solve. If specifically it is given find inverse by row transformation, then you have to find by row transformation. If it is given by column, you have to solve by column transformation. Now here find the inverse by transformation method. So here we will use the row transformation. So first step, A is given matrix. First step, find the determinant of A. Determinant of A means solve the determinant, you will get the value minus 5. So minus 5 not equal to 0, therefore you will write A inverse exist. Next step, always you have to do this step for finding the inverse, A inverse by any method. Now if you are solving by row transformation, then the formula is A into A inverse is equal to I. Always remember, if you are using row transformation, you have to use A into A inverse is equal to I, and if you are using column transformation, then A inverse into A is equal to I. This interchange, this will go here and this will come here. So now we are solving by row transformation. So A is given, right? A matrix as it is, then A inverse that we have to find, and I means take 2 by 2 identity matrix. This is 1 0 0 1. This is identity matrix. Now this A we have to convert into identity matrix. Then when you do the transformation to left hand side, that same transformation you have to carry out to the right hand side. So you will get the value of A inverse. Now according to the method, first this is A matrix, this you have to convert into 1, and then using this one you have to convert it into 0. Then next this you have to convert into 1, and this you have to convert into 1 by dividing by the same number, and by using, when you convert this into 1, easily you can convert this into 0. So you will get identity matrix. So start from here. First you have to convert this into 1 and then this into 0. So already this is 1. Now we will convert this 2 into 0. So how to convert this 2 into 0? It becomes easy when here 1 is there. So we can convert this into easily. That's why first convert this into 1 and then this convert into 0. But here already 1 is there. So what we will do? This we will convert into 0. So we are doing by row transformation. So say we will make change in this second row. So R2 changes to R2 minus 2R1. Suppose you will multiply this 1 by 2, then 2 minus 2 will be 0. So here we can get 0 easily when here it is, when 1 is there here. So first we will do R2 changes to R2 minus 2R1. There is change in R2, therefore we will write 1 as it, R1 row as it is. So R2 here do this transformation, here we will get 0, and here minus 1 minus 1 minus 2 into 2. So minus 1 minus 4 is equal to minus 5 into A inverse is equal to first row as it is, and same transformation we have to carry out right side also. So R2 minus 2 into R1, that is R2 means 0 minus 2 into R1 means minus 2 into 1 is minus 2, and R2 means 1 minus 2 into 0 is 0, so here it becomes 1. Now here it has become 0. Now we have to convert this into 1. But if we do any change, if we do transformation with R1, then this will also change. So only the best way to convert this into 1 is divide it by itself. So it will become 1. So now we are going to make change in R2. So R2 changes to, here minus 5 is there. So when it will become 1? When you will divide it by minus 5. So minus 1 upon 5 into R2. R2 changes to minus 1 upon 5 into R2. So there is no change in R1, right as it is. This 0 into minus 1 upon 5 is 0, and minus 1 upon 5 into minus 5 is 1. Same transformation do it here. This 1 and 0 as it is. Minus 2 into minus 1 upon 5 is plus 2 upon 5, and 1 into minus 1 upon 5 is minus 1 upon 5. Same transformation you have to do to the both the RHS and LHS. Now this one we have got. Now this we have to convert into 0, means we have to change, we have to make change in R1. So now here 1 is there, so easily we can make this 2 as 0. Here no change will be there because here 0 will be there. So R1 changes to R1 minus 2R2. You see, when 1 is there, we can change it very easily. So R1 changes to R1 minus 2R2. R2 write as it is, and here it will remain 1 only, and R1 minus 2R2 means 2 into 1, minus 2 and 2 minus 2 is, say R1, there is change in R1, so R1 2 minus 2 into 1 is 2, 2 minus 2 is 0, and same you have to do it here. So R2 write as it is and make change in this. So R1 means 1 minus 2 into 2 upon 5. See here I have done the calculation, 1 minus 2 into 2 upon 5, that is 1 minus 4 upon 5, that is 1 upon 5, 1 upon 5, same like that only here. Now here this is a, we have converted this into identity matrix, so we will write here I into A inverse is equal to this right hand side matrix as is. But see here 1 upon 5 is common, so we can take, this answer is also correct, but if you want you can take 1 upon 5 common. What remains? 1 2 2 minus 1. So A inverse is equal to 1 upon 5 and matrix 1 2 2 minus 1. Next is see this is 3 by 3 matrix, so more transformations will be there in this. So this is matrix A is given, which is of the order 3 by 3. So first step is you have to find value of determinant which should not equal to 0. So the value of determinant is 1, which is not equal to 0, so A inverse exists. This sum also we will solve by row transformation. So for row transformation, what is the formula? A into A inverse is equal to I. So this A given matrix write as it is A inverse, and I we have to take 3 by 3 identity matrix. Now first what you have to do, this you have to convert into 1. When you convert this into 1, we can make easily this and this 0. Okay, so this is 0 only, we have to convert this into 0. So first make, always remember this you have to convert into 1. So how to convert? So we will make the changes in R1. R1 changes to 3R1 minus R2. See, when you multiply this by 3, it becomes 6, and 6 minus 5 is 1. So this we have to convert into 1. So we will use the transformation 3R1 minus R2. So we will write and take R2 and R3 as it is. So only the change will be there in first row. So it becomes 1. Now 3R1 means 3 into R1, that is 0, minus R2. Minus R2 is minus and is 1. So it becomes minus 1. And 3R1 minus R2. 3R1 means 3 into minus 1, that is 3, minus 0 is minus 3. Same transformation you have to carry out to the right hand side. That is 3R1 here, 3R1 minus R2. So 3 into 1, 3. 3R1 minus R2. This is 0 and is minus 1. And it will become 0 only. Now we have new matrix is this one. Now we have to convert this 5 into 0. So means this we have to convert into identity matrix. So this 1 we have converted this into 1. Now this 5 we will convert into 0. So how will, when this becomes 1, it becomes easy. So if you multiply this by 5 and then this minus this you will do. This multiply by 5 and then R2 minus R1 you will do. It will become 0 easily. So next transformation on R2 we have to do, because this 5 we have to convert into 0. So R2 changes to R2 minus 5 R1. First row and third row write as it is. Now R2 minus 5 R1, this is 0. This R2 means 1 minus 5 into minus 1, 6 it will become, and R2 0 minus 5 minus 3 means plus 15, and this third row as it is. Then see same transformation you have to do to the right hand side. So first and third as it is, and R2 means 0 minus 5 into 3 minus 15. 1 minus 5 into minus 1. So this 1 and 5 ones are 5, that is 6, and this is 0 only. So same transformation carry out to this side. Now next step will be this, you have to convert into 0, but already this is 0. Now next step will be this 6 you have to convert into 0, 1. When you convert this into 1, we can make this easily 0. So to convert this into 1, say here 1 is there and here 6 is there. If you interchange second and third row, here it will become 1. So R2 and R3, they are interchanged. So like this double arrow, the sign will be of double arrow. Then first row and here also first row, right, as it is, and interchange. So 0 1 3 will come here and 0 6 15 will come here. Here also 0 0 1 will come here and minus 15 6 and 0 will come here. So now here also it has become 1. Now we will convert this. This has become 1, so we can convert this into, we will convert this into 0. Now R1 changes to R1 plus R2. Add it, R1 plus R2. So here R1, here minus 1 and 1 is there, so it will become 0. So write R2 and R3 here also and here also as it is, and make transformation. R1 changes to R1 plus R2. So it will become 1 0 0 and here 3 minus 1 1. Now here we got 0, here we got 0. Now we will convert this 6 into 0. Okay. Now R3 changes to R3 minus, see, if when this become 1, we can convert easily this to 0. So R3 changes to R3 minus 6 R2. When this 1 is multiplied by 6 and 6 minus 6 will become 0. So write down first and third row as it is, here also and here also. Then R3 minus 6 R2. Here 0 is there, no change will be there. Then see, so here 0 is there, no change will be there here. And here also 0 is there. Now here 6 minus 6, it will be 0. Here 0, no change. And here R3 means 15 minus 6 into 3. 6 3s are 18. 15 minus 18 is minus 3. Same here also R3 minus 6 R2. Here 0 is there, so here minus 15. Here 6 minus, here 0 is there, so here 6, and here 0 is there, so minus 6 into 1 is minus 6. After this, we have to convert this into, next step, this into 1. See, diagonal 1 should be there, so here we have to convert into 1. So if you do transformation with other row, there will be change, and the zeros and 1 will be changed. So what we will do, divide minus 3 by 3. Here if you divide, no change will be there. When you divide minus 3 by 3, here you will get 1. So minus 1 upon 3 R3. So here 1 will come, here no change. Here divide by minus 3. So here 5, here minus 2, and here 2. Now what remain? Here 3 is remaining, there this we have to convert into 0. So we have to make change in this second row. See, here 1 is there, so it will be very easy to convert this into 0. So 3, if you multiply this 1 by 3, 3 minus 3 will be 0. So what transformation you will do? R2 minus 3 R3. This one multiply by 3. So first and third row write as it is and convert second row. So 0 R2 minus 3 R3. Here 0 is no change. Here also no change will be there. And here 3 minus 3 into 1. So it becomes 0. Same transformation. Write 1 and first and third row as it is, and do transformation on the second row. Now see this matrix, it has become the identity matrix. So we will write here I, and this A inverse as it is, and this new matrix which we got to the right hand side. So I means identity matrix. Identity matrix multiply by any will remain that number, that matrix only. So A inverse is equal to 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. So this was the row transformation. Row transformation formula you have to remember, A into A inverse is equal to I. Now question number 7 is there. In question number 7 you have to find A inverse by column transformation. Still we are doing by row transformation. So now we will do by column transformation. Always first step, write it in the matrix form. I write it, I have not, by mistake I have not written, so write it in the matrix form and solve it. After solving you get minus 6 which is not equal to 0, therefore A inverse exists. Now see formula for column transformation. Formula for column transformation is A inverse into A is equal to I. For row it was A into A inverse is equal to I. So here first you will take A inverse and then A. So A inverse and this A matrix write as it is, and I means 3 by 3 identity matrix. Now remember column transformation is that you have to do transformation on column only. Now first see here, this you have to convert into 1 and this all you have to convert into 0. So first this we will convert into, in row we were converting this into 1 first. Now this we will convert into 0 first for column transformation. So this here also 1 is there, here also 1 is there. If you minus C3 and C1 you will get here 0. So we will do the transformation. C3 is converted into C3 minus C1. So first second column as it is, here also first and second column as it is. Now 1 minus 1 0, 3 minus 0 3, and 1 minus 1 0. Here also 0 minus 1 minus 1, 0 minus 0 0, 1 minus 0 1. Now next one we will do transformation on C2. We will convert this 1 in this 2 into 1 because we want here 1 is there, we want here 1 to convert into identity matrix. So when you convert this into 1, easily we can convert this into 0. Here when if you convert this into 1, we will convert this into 0. So first transformation will be there on C2 converts to 2C2 minus C3. So this and this first and third column write as it is. Now see C2 converts to 2C2 minus C3. So 2C2 minus C3. So here 0, 0 minus 0, 0. Then 2C2 means 2 2s are 4 minus 3, 1. So we got here 1. And 2C2 means 2, 2 2s are 4 minus 0 is 4. And this as it is. Here also 2C2 minus C3. 2C2 is 0 and this is minus becomes 4 plus, and this is 1. 2C2 means 1, 2 into 1 2 minus 0 is 2, and 2C2 means 0 into 2 into 0 0, and this minus C3 means minus 1. So now here we got 1. Now we can make this easily, we can make this 3 as 0. Then see we have to convert this C3. Here we want 0. So if you multiply this by 3 and subtract this 2, you will get 0. So C3 changes to C3 minus 3 into C2. So first write down first and second column here and here also same as it is, and then convert C3 minus 3 into C2. 0 will remain 0. 3 minus this 3 into 1 is 3. 3 minus 3 will be 0. And this C3, this 0 minus 3 into 4 is 12, that is minus 12. And then here also C3 C3 minus 3 into C2 means 3 into C2 is 3 into C2, that is minus 3. Minus 1 minus 3 is minus 4. Here also 3 C2 means 3 2s are minus 6, and here 3 minus 3 into 1 is 3, and this 1, which is equal to 4. So C3 changes to C3 minus 3 2 here. So here we got 0. Now this 12 is there. This 12, we want to convert this 12 into minus 12 into 1. Okay, because we want identity matrix. So if you make this any transformation, then it will change. So we will divide it by minus 12. So C3 will be changed into minus 1 upon 12 into C3. So C1 and C2 and C1 and C2 as it is, and divide by minus 12. So here no change, and here minus 12 upon minus 12 will be 1, and here minus 4 into minus 1 upon 12 is 1 upon 3, minus 6 into minus 1 upon 12 is half, and 4 into minus 1 upon 12 is minus 1 upon 3. So now this also we have converted into 0. Now this we have to convert into 0, and then this also we have to convert into 0. So first we will convert 1 into 0. So C3 minus C1, if you do C1 minus C3, so 1 minus 1 0. So remaining two columns write as it is, and do C1 minus C3. Say 1 minus 0 1 minus 0 1, 0 minus 0 0, and 1 minus 1 0. Here also 1 minus 1 upon 3 is 2 upon 3, 0 minus half is minus half, and 0 minus 1 upon 3 is plus 1 upon 3, and this two columns as it is. Now only this 4 is remaining, that we have to convert into 0. Now here 1 is there. See, when 1 is there, we can convert this 4 easily into 0. If you multiply this 1 by 4 and this subtract this 2, you will get it 0. So C2 changes to C2 minus 4 C3. So first and third column as it is, and say C2 minus 4 C3. So here no change will be there, and C2 minus 4 C3 means 4 minus 4 into 1, that is 4 minus 4 is 0. So say 1 is there, easily we can convert the remaining into 0. Here also say C2 minus 4 C3, C2 minus 4 upon 3. So you will get 1 upon 3. Here half, here 0 is there, and C2 means 1 upon 3 minus 4 upon 3. So you will get minus 1 upon 3. Now this is the identity matrix. So A inverse into I, this is identity matrix, is equal to right hand side matrix. So A inverse into I is A inverse, which is 2 upon 3 minus 1 upon 3 minus half 0 1 upon 2 1 upon 3 1 upon 3 and minus 1 upon 3. Up to here also no need of simplifying. If something any common you can take, but no need. If up to here also you will solve, the answer is